Good afternoon, everyone. Yes, good afternoon. Right. So since Anjana ma'am is not well today, I'll be taking your class. Okay. So I won't be continuing what Anjana ma'am was teaching. Okay. Instead, I'll just focus on named reaction mechanism. Okay. Okay, everyone. Around 26 of you have joined. Okay. So I'll start the class. So I hope that you have completed aldehyde and ketone, right? Right, everyone. Just let me know. I think it's been completed, right? It's already completed in your class. Okay. Okay. So most of you, okay, very good. Yeah. So it's been completed, right? So we will be discussing some mechanism which has already been completed. Okay. Right. And some mechanism we will discuss new. Okay. So I hope all of you went through NCRT, right? All of you went through NCRT of aldehyde and ketones, right? Okay. Okay, everyone. So we'll start with basic mechanism. As I told you, we will start with basic mechanism. Now, when we talk about name reaction mechanism, right? So we have different type of reactions. Okay. Till now, we have studied different type of reactions: addition, substitution, elimination, right? But when we talk about aldehyde and ketone, then we have one reaction, right? Which we studied, right? Which is condensation reaction, right, everyone? Okay, I hope everyone remember condensation reaction. Now, when we talk about it, condensation reaction, okay, so we will discuss the mechanism of this condensation reaction. Now, before starting this, right, I want to know how many of you know the mechanism of SN1, SN2, E1, E2, right? I hope everyone know that. I need not to teach those things. Yes, I hope that I need not to teach those things, right? All of you know SMR, SN2 and all those things, okay? Now, when we talk about aldehyde and ketone, right? So there are actually two mechanisms which is very predominant in the throughout the chapter, right? Now, when we talk about this, just think about this, right? We have R, C double bond O, X plus NU, right? I hope all of you are quite aware of this reaction. Yes, tell me. Yes, it's a very famous reaction of aldehyde and ketone. Now tell me what would be the product? Yes, it is. Okay, very good. Right? Now, most of you said that it will be R, C1O, and U, right? This is nucleophilic substitution through acyl intermediate. Yes? Yes, everyone? We have studied that? Okay, right? Now, this is when X is your leaving group. When X is leaving group. Leaving group. Right, everyone? Agree? Leaving group, any leaving group. Okay, now suppose if X is your hydrogen or any alkyl group or phenyl, then what? Then tell me, then what will happen? So you can say that it is your substitution. Substitution, right? And this reaction will be what? This reaction will be very basic. I'm just asking very basic question, okay? So obviously, right, nucleophile will attack, yes or no? Tell me, nucleophile will attack because when we talk about the mechanism, right, let's see the mechanism of either substitution or this. The first step of nucleophilic substitution through acyl intermediate, right, is breaking up this bond, yes or no, right? Okay, so we will get an nucleophile will attack this side. Okay, so we will get something like this: R C O minus X and U. I hope everyone remember this. Now, if this is your living group, right? If this is your living group, then this leave, right, resulting in the formation of positive charge, okay, and then negative positive, right? But suppose if it is not your leaving group, suppose this is not your leaving group, then what? Then this will be your product, right? This is your addition product, right, everyone? Right? This is what we have already studied. Yes, I'm just revising this basic concept. Okay, right? Now, this is actually the basic mechanism that you have studied in almost 70 to 80% of reaction. Yes or no? Tell me, right? Tell me, yes or no? Yes, nucleophile has changed. Either nucleophile has changed or leaving group has changed. That's it, right? Otherwise, most of the reaction, be it condensation reaction, be it your aldol or canizaro, right? Whatever reaction we studied, right? This is just this simple mechanism. Okay? Okay, everyone. Right? So we will discuss the mechanism one by one, right? I'll focus on those reactions which is not commonly known, okay? Because I guess that most of the common reactions have already been covered, aldol, ketone, and all those things, okay? So we'll be talking about those reactions which is not covered, right? Which is a bit different, okay? Right, everyone? Okay. So today we are, yeah. So today we will be covering these reactions. Okay. So today we will be covering these reactions. Now, among these reactions, there are some reactions which you have to learn thoroughly, right? Which means you have to know the mechanism also, right? Aldol, Aldol, Perkins condensation, Perkins, right? Reformatsky, Canizaro, right? Protease synthesis. These reactions you have to know with the mechanism. Rest, you just have to know the reaction. Okay, benzyl, benzylic also, you just have to know the reaction. Now, when we talk about these reactions, right, most of them, the first three are condensation reaction. Okay, so the mechanism will almost be same, right? The only difference would be either substrate, leaving group, or nucleophile. Okay, so we'll discuss each reaction one by one. Okay. Now, when we talk about aldol, aldol is the most common and the most famous reaction of class 12. Yes, everyone? I hope that everyone remember aldol condensation. Now, when we talk about reaction, right? When we talk about reaction, be it name reaction, any reaction, we have to know three things. As I have always said, you have to know three things, right? First is reactant. Second is your reagent, and third is your product, right? Product. Because if you don't even know the mechanism, right, and if you know these three things, okay, you would be able to solve each and every question of mains, NEET, okay, mains and NEET and CT and all their examination, okay, even if you have some doubts in mechanism, right, but you know these three things, reactant, reagent, and product, you would be able to solve the reaction, okay. Now, when we talk about reactant, so we know that in aldol condensation, reactant should be what? Tell me. Reactant should be aldehyde or ketone. Yes? Yes, aldehyde or ketone. Okay. Now, this is a reactant. Is there any condition? Tell me, is there any condition? Yes. So I can say that here reactant is, right, aldehyde or ketone, right, with at least one alpha hydrogen. With at least one alpha hydrogen. Yes, right? That is the condition. That is your reactant. Okay. Now, when we talk about reagent, now reagent is base. As simple as that. Reagent is base. Okay. Now, when we talk about the mechanism, right? Just think about this. We have aldehyde, nothing else, and we have a base. Okay. most of you might think, okay, if we have a base, right, there might be, because there are some students who thought like this. Suppose we have CH3 C double bond O H, right? So some of you might have thought like this, right? So you just said, wait everyone, I think that I got a call, so my voice would be less, right? Wait for 2 minutes. Okay, I'm audible, right? Apologies, my voice drops whenever I get a call from someone. Okay, okay. So yeah, when we talk about base, so someone might think, okay, so we will follow the same procedure, right? You said that if we have a nucleophile, because here base OH minus can also act as a nucleophile. So someone might think like this, right? So this will react here, but since we will have two OH on this carbon, right? It will again form this aldehyde or ketone, right? So obviously this nucleophile, which is OH minus, will not attack here, right? Will not attack here. Got it? Right? Yes. Okay. Now in acetyl we do so, but in that case we have H2O. Okay, H2O, right? And we have studied that acetyl or hemiacetal exists only in water, right? Except for chloral hydrate. Okay, but here we don't have that, right, everyone? And 2OH on one carbon is highly unstable, right? Whenever we have this, the H2O will be removed, leading the formation of double bond O. Okay. Now, if it will not react like this, then what? Then what happens? This OH minus will act as a base, right? So the first step is it will remove alpha hydrogen, which is an acidic hydrogen, right? So when we have two aldehyde or one ketone or two ketone, right? This OH will first remove the acidic hydrogen, which is alpha hydrogen. Then that molecule will become your nucleophile. Okay, instead of OH minus, that will become your nucleophile. Okay, okay, everyone. So if you observe the mechanism, right? If you observe the mechanism, so this is what I said, that the first step is always removal of this hydrogen by OH minus by base, so that it will become your nucleophile. Okay, it will become your nucleophile. Okay, now this, right? Now if it becomes nucleophile, it will again they follow the same mechanism as nucleophilic addition that I said. Okay, right, everyone? So it will attack here. Okay, we will have a condensation product. Now condensation product is nothing but the combination of, or it's just the addition of nucleophile, right, everyone? If you think that this is a nucleophile and it is nothing but addition of nucleophile, right, everyone? Okay, so every condensation reaction can be said as it is nucleophilic addition reaction. Okay, where the nucleophile is your, tell me, what is your nucleophile? Is your another substrate which has been converted into nucleophile. Yes, yes, carbonium ion. Okay, got it? Right? Now, why aldol condensation is the base of every condensation? Because when we talk about any other condensation, be it Perkins or be it your Claisen ester condensation, right? Everything will be same. The mechanism will be same. The only difference would be your leaving group and substrate. Okay, right, everyone? Okay. Now, we have studied your base catalyzed aldol condensation. Now, when we talk about AC catalyzed, right? Even AC catalyzed, almost follow the same procedure, right? But you must think that how we can remove, okay, H plus when it is acid catalyzed, right? Right, everyone? Now, in our syllabus, right, whatever we have studied till now, we have used just base catalyzed, right, everyone? We haven't used acid catalyzed, okay? Now, when we think about this, just think from open mind, right? What will happen when we give acid, H plus? Because base catalyzed is very simple, right? We have always studied that for aldol condensation, base is required, right? It is base catalyzed reaction. Now, just think about this, right? Just think about this. You can skip it also. I'm just explaining is if you get this, good. If you don't get this, don't worry, right? So when we give H plus to aldehyde or ketone, right, what will happen? This H plus will obviously go here and will form OH plus. Yes, agree? Agree, everyone? Right? Now this will have a tautomeric product like this. Okay? Now, when we talk about this, right? When we talk about this, now when we have this tautomeric product, right? This pi bond will break. Okay, when this pi bond will break, we have a positive charge here. Why? Because this lone pair will go here and we will have a negative charge over here, right? Ultimately, it will be the formation of nucleophile, but how nucleophile is being formed, that is something different, right? Otherwise, all the process will be same. Okay, everyone? Got it? Right? Okay, so that is the difference between acid catalyzed and base catalyzed, right? So the two additional steps we have to think. First, H will attack on oxygen, right? Then it will tautomerize. Then this pi bond will break and it will attack as a nucleophile, right? Everything else would be same. Okay, but we have to focus on base catalyzed mechanism. We don't have to worry about acid catalyzed mechanism. Okay, now, right? Think about this, right? Everyone, think about this. So we have a problem over here. Just write the product. You just have to write the product. I'm giving you 5 minutes. Okay, right? Just write the product. Try to solve this one. I hope that question number 1 would be easy, right? I hope that 1 and 3 would be easy, as well as this 5th one, right? Actually, 2nd and 4th is also easy if you have actually practiced, right? All of them would be easy. Okay, but 1, 3, and 5 you have already practiced, I guess. Yes. Now, when we talk about 2nd and 4th, right, the extent of aldol condensation will be very less. Agree? Yes or no? The extent of aldol condensation in 2nd and 4th will be less, right? Because ketone have less tendency for aldol condensation. Okay, right? Got it, everyone? But you can form the product. Anyways, you can form the product, right? Even if the percentage yield will be less, it will form. Okay? Now, I hope all of you can solve this. Do I need to solve this? Tell me if you have any doubt. Please ask. Okay? Right? Now, my question is, I'm having a question, right? So here we have self-aldol condensation. So when we have self-aldol condensation, we don't have any issue. But suppose we have cross-aldol condensation, okay? Cross-aldol condensation, and when we have one aldehyde and one ketone, right? One aldehyde and one ketone. Then what do you think? Out of which will and which will be substrate? Tell me. Suppose I'm having cross-aldol condensation, which will be nucleophile, which will be aldehyde. Sorry, which will be substrate. Ketone or aldehyde, right? Out of them, which will be nucleophile, which will be substrate? Yes, very good, right? So whenever we have, remember this, right? Whenever we have aldehyde plus ketone, okay, plus ketone. Now, when we talk about nucleophilic addition or nucleophilic substitution, right, we have two factors which affect the rate of a reaction, right? The two factors are, first is your steric repulsion, okay, right? And second is your nucleophilicity, right? Sorry, nucleophilic center, right? So delta plus, how much delta plus is here? And second, the steric repulsion between these two groups, okay? But when we talk about this reaction, okay, we give uh, priority to steric hindrance. Unless until we have very strong group, we give priority to steric hindrance. Okay. Now we know that in case of ketone and aldehyde, due to steric hindrance, ketone will be less reactive to nucleophilic addition. Yes or no? Tell me. Yes. Okay. As compared to aldehyde, obviously, when we talk about steric repulsion, okay, when we talk about rate, it is relative. It is always related to something. So ketone will have less rate of reaction as compared to aldehyde. Okay, that's why whenever we have aldehyde and ketone, the major product ketone will always be nucleophile, right? Nucleophile, and aldehyde will be substrate. Okay, right, everyone? Okay, now even if we have two aldehydes, then the aldehyde having less steric repulsion will be your substrate, and aldehyde having more steric repulsion will be your nucleophile. Okay, chemistry message on host. You're messaging on co-host, I guess. Tisha, you also messaging on co-host. Okay, I'm not checking message on co-host. Okay, so if you have any doubt, please message on host. Okay. Okay, now when we talk about aldol, right, we have three things. Actually, we have normal aldol, right? Actually, four, not three. Normal aldol, cross aldol, right? Intramolecular aldol, and retroaldol. Yes, right? So this is your normal aldol, self-aldol condensation is your normal aldol condensation. Mechanism is same, doesn't matter which, except for retroaldol. Okay, now, when we talk about aldol, it is your self-aldol condensation. Cross-aldol condensation, in which we have two different aldehyde or ketone, right? That's a cross-aldol condensation. We have multiple products. I guess all of you have already studied that. Now, we have intramolecular aldol condensation. In intramolecular aldol condensation, we have two aldehydes or two ketones in the same group, right? In the same molecule. In that, there's a formation of ring. Okay, there's a formation of ring. Okay, everyone, right? Now the mechanism will be same. Again, mechanism will be same. There will be no difference in mechanism, right? So when we talk about question number 2, right? Question number 2. I hope all of you can, yeah, all of you can write the product. Yes. Now, my question would be, I'll just explain this, right? I'll just take one example. I'll just take example number 1. Okay, so you may ask, sir, we have alpha hydrogen here also, alpha hydrogen here also. Since it is symmetrical, doesn't matter if I'm taking this or this. So which of the two alpha hydrogen should I remove, right? Now that depends on the, tell me, that depends on what? The ring size. Okay, that depends on ring size, right? For example, in question number 2, in question 1, obviously you will remove this, right? And it will attack here, sorry, here, right? So the ring size will be 1, 2, 3, 4, and 5. Okay, 5 ring. But if you do the same in this one, if you do the same in this one, right? If you'll do this. So we'll have 1, 2, 3, 4, 5, 6, 7. Right, everyone? Okay, right? And if you attack this one, then we'll have 5. So obviously 5 would be preferred over 7. Okay, so ring size will be one of the factors. Okay, okay, everyone, right? I hope all of you got this. Yes or no? Tell me, all of you got this, right? Okay. Now, see this, whenever heat is given, you have to notice this also. Whenever heat is given, you have to remove OH and form double bond, right? But if heat is not given, normally you should not remove OH. But obviously in some cases, in some textbook, in some previous year, right, they have removed OH, right? For that, just see the options, okay? Right? Don't be adamant, right? So OH, it is not given, still it has removed OH. Just see the option, go with the option, okay? Because you have to solve the problem. You don't have to argue that sir, heat is not given, then why they have removed OH, right? Go with the option, right? If they have removed OH, okay, in all the options, right? Instead of OH, then you can consider that as your answer, okay? Okay, everyone? Okay, so this was about aldol. I guess all of you have already studied aldol a lot. Okay, so can solve all these exercises. Now, second is Bayesian condensation. As name suggests, it is also a form of condensation. It is also called as Bayesian ester condensation. Okay, now as it is a condensation reaction, the mechanism would be same. The only difference would be substrate, okay, and nucleophile. Now see this, see this. We have CH3, C bond O, OCH3, right? Here I'm giving, in one case, OH minus, in one case, OCH3 minus, and in other case, I'm giving OC2H5 minus, right? Now tell me, out of these three reagents, which will leads to formation of condensation product? Tell me, out of these three reagents, which will leads to formation of condensation product? This is A, this is A, this is B, and this is C. Tell me, A, B, or C, and why? Think about it. Think about it, everyone. Tisha, think again. I ask you reason also, okay? Right? Tell me the reason also. Now, if you actually understand the mechanism, that's why I focused on mechanism, right? Before starting aldol, what misconception I told you? Tell me, right? What misconception I told you? That why OH will not act as a nucleophile? Why it will act as a base? Yes or no? Right? In first and second case, condensation will not occur, right? First and second case, we will just have nucleophilic substitution reaction. Okay, agree? Because OCH3 will act as a living group. Okay, so first case will lead to the formation of carboxylic acid, and second will lead to the formation of another ester. Okay, got it everyone? So first and second will not have your condensation product. Everyone is getting this? Yes or no? Right? That is a basic concept. Okay. Now see the third one. See the third one. Right? The base that I have taken in third case is same as the living group. Yes or no? Is same as the living group? Yes. Now, when it is same as a living group, right? Obviously, it will not behave as a nucleophile. It will behave as a base. Yes or no? Yes or no? Yes. Right? So what will happen? Tell me, what will happen? If it is acting as a base, it will try to remove H plus, same as aldol, right? And it will remove H plus from where? From this carbon, right? From this carbon. Okay? Yes, SD hydrogen from this carbon. Are you getting the point? Yes? See, that's the thing, right? If you understand the basic of mechanism, everything is easy. Okay? Now, once you have a nucleophile, you have this double bond O, everything will be same as aldol condensation. So let's see the mechanism one by one, right? Step by step, right? Now see this. The first step is formation of nucleophile. Yes or no, right? The second step is again same as aldol. This will attack on silver bond O, right? Third step is this, which is same as nucleophilic substitution through acyl intermediate, right? And then tell me, then this OR will remove. Yes or no? Tell me. Because this OR is your living group, right? In that case, OH was removed. Here, OR will remove. Okay, OR will remove because it is your living group. Okay, so we'll have this. Everyone got this? Tell me, everyone got this mechanism? Anyone have any doubt in this mechanism? Tell me. The only thing that changed here is your reactant, right? And reagent. Otherwise, everything is same. Mechanism will be same. That's why I said that the condensation mechanism will almost be same. Okay, for all the condensation reaction. Got it, everyone? Tell me, anyone have any doubt in this? Okay, so what is the condition for ester condensation? Tell me, what is the condition for Claisian ester condensation? Tell me, we just saw that. Yes, nucleophile, right, should be same as the living group, right? The R in nucleophile should be same as the living group, okay? Okay, everyone. Now, we'll see some problems of this. Try these three problems, everyone. Try these three problems. I'll solve this because we haven't done this problem. Okay, you might have done, I don't know actually, right? But at least try these three problems once again. Okay, let's solve. I'll solve one problem. I'll solve this third one. Okay, I'll solve this third one. Now tell me, in third one, right? In third one, which will be your nucleophile? Tell me. In third one, which will be your nucleophile? This is A, this is B. Tell me, A or B, which will be your nucleophile? A or B? I'll just write the structure, okay? We have CH3, C1O, OMe, then we have C2H5, C1O, OMe. Yes, B, right? Okay, because we will have less repulsion in case of A, okay, right? So we will have something like this, CH3, CH2. So this hydrogen will be removed and this will attack here, okay, right everyone? And then this OMe will be removed, okay? Got it everyone? Tell me, everyone got this? So just form this bond and remove this OMe, right? Remove this OMe, that is your product. I hope all of you understood this. It is easy, right? And we have CH here, over here, not CH2, we'll have CH. Okay? Okay, everyone. Okay. So anyone having any doubt in Claisen ester condensation? It is same as aldol condensation, right? The only difference is the reactant is ester instead of aldehyde and ketone. Okay, right? Now, Perkins condensation, right? Perkins condensation. Now think about this. When we talk about Perkins condensation, okay, again, mechanism would be same. Mechanism will almost be same. The only difference would be reactant and reagent. So think about this. We have benzaldehyde, right? This is your benzaldehyde and this is your anhydride, right? So the reactant should be what? Anhydride, right? And aromatic aldehyde. Okay, so Perkins reaction, Perkins condensation is a condensation reaction between aromatic aldehyde and anhydride, aliphatic acid anhydride. Okay, right? And see, when we talk about condensation, if you don't remember anything, right? If you just got blackout, just think that the region would be base, right? It would be base. Yes, agree? Okay, so here we have sodium or potassium salt of this anhydride. Okay, right? Same as Claisen ester condensation. Okay, same as Claisen ester condensation, right? Now just think about this. I'll give you 2 minutes. Try to think because this is your product. I have given you product. Try to think about the mechanism. Okay, everyone. Try to think about the mechanism. What happens, right? This is acting as a base. Then what happens? Try to think about the mechanism. Okay, everyone. So first step is, right, this will act as a base, yes or no? Tell me. First step, this will act as a base, right? Yes. Second step, it will remove OH minus, sorry, H minus, sorry, H plus, right? It will remove H plus from where? From, obviously, we don't have H plus in aromatic aldehyde. We have H plus in anhydride. So it will remove H plus from here, yes, CH3. So it will form CH2 minus, right? Yes, from anhydride. Then it will attack on aromatic aldehyde, right? Then something will leave as a living group, right? Yes. So I'll give you 2 minutes. Please try to write the mechanism. Okay? Please try to write the mechanism. What is the total strength of your class? Total, I guess it is 33, including Sumedh and Tamujit, it's 33. Isha, try to think about the total mechanism, right? We have O, living group is H2O. Just think about this living group, right? Is living group H2O here? It is same as, right? It is almost same as Claisian ester condensation, right? In case of Claisian ester condensation, living group was OR, right? Yes? Okay. Now, see everyone, see this. Right, as I said, the first step is removal of H plus. We will get this as your nucleophile. Got it? Right? Then same mechanism as aldol, it will attack on this carbon. We will have this condensation product. Now, if you see this, right? If you see this, what will happen? We have an acid here. So this O minus will take this H plus, right? This is a very small reaction. Don't worry about that. So we'll get this, yes or no, right? But again, we have H plus slash H2O. Now in this, which is your living group? Tell me, which is your living group? Think about this. In this whole big compound, which is your living group? Don't you think that this is your living group? Right? And H2O, OH will attack here. Yes. So we will have nucleophilic substitution reaction over here again, right? So this whole group will be replaced by OH group, as simple as that. And this is your, right? Now, when you give heat, what will happen? This OH and this H will remove and we will have double bond as same as aldol condensation, step by step. Yes, dehydration, right? This is a normal reaction now. It is one of the method to prepare alkene, if you remember, right? Dehydration is one of the method to prepare alkene. Okay, right? So we will get this, right? This is also called as cinnamic acid. Okay, got it everyone? Just have a look. If you want to note it down, you can note it down, right? But if you observe the three mechanisms, right, then you can get the idea of any condensation reaction. Yes or no? Because in exam, you might not be given the name, but you might be given the condensation reaction. Okay, right? So if you actually know the mechanism, everything would be easy. It is same mechanism, right? Nucleophile will attack, first formation of nucleophile, second nucleophile will attack, right? Then removal of living group. As simple as that. Okay? So everyone is getting this? Tell me, everyone is getting this? Yes or no? Okay? Try solving this, everyone. Try solving this. Very good, Amruta. Try solving this. Kalpana is absent, and who else is absent? Abhin is absent. Yeah, Prashant is absent. So we have total of 6 students absent. We'll see. Anyways, and Abhinav, obviously, he is always absent. He's the smartest guy in the classroom, I guess. He knows everything. There he is. Abhinav, are you here? Okay, don't worry, it's fine. I'll just speak to everyone who is absent. Okay, so I guess all of you understood this. Tell me, do not get confused by the size of the compound. Okay, right? Do not get confused by the size of the compound. If the size of the compound bothers you, right, just use R and just substitute the R in the last, as simple as that. Okay, right? So I hope all of you have solved this. Let's see. I'll just draw the product, right? You will just see the product. Now it will be same as it is. So it will be H3CO. Now this is 5. I just write benzene as 5C. Now this O will become OH, right? I'm just writing one step, then I'll dehydrate. Okay. Then after this we have this group, this big group, right? So it will be C. Now see this. After C we have how many carbon? 2. So it is ET. Double bond O, ET, right? Got it? Tell me yes or no. Right? Wait. Wait, wait, wait. Wait. My laptop got hanged. Wait some time. Okay, yeah. Sorry. Okay, so it is ET, right? So we will think about this CH3, CH2, right? Silver bond O, right? And then you have living group L. Now, when you take it as a base, so this hydrogen will be removed, right? So you will have CH minus over here, right? And this will attack. Got it, everyone? Got it? This will attack? Yes or no? Mashri, are you getting? No? Then what? Tell me. Just think about this. What is this product? This is this now. CH3, CH2, C double bond O, then again O, C double bond O, CH2, CH3, right? This is your total anhydride. This is a total anhydride. So I just took this as living group L. Got it? Right? This is what L, and this is what remaining group. I'm just forming the product, Vishnu. I'm just writing the product. Okay, right? So this is your nucleophile, yes or no? Okay, this is your anhydride and this is your base, right? So base will just remove H plus from where? From the alpha hydrogen, right? Now this is a nucleophile. So nucleophile will attack on this carbon, right? Which is this carbon. So we have, right? Now, obviously we'll have one H, right? I just form OH. I took H from an acid, this H plus. Now this will attack over here, right? So there's a form, sorry, there's a bond between this carbon and this carbon. Yes or no? Tell me, yes or no? Yes, right? So if you think about this, so I'll just form a bond. Just write it here. So we'll have CH3, right? Because this CH3 to CH3, then C double bond O, and now this was L, which will be replaced by OH. Agree? Agree, everyone? Right? So please check your answer. Now, after dehydration, After dehydration, we have this H here, right? This OH and this H will be removed. We'll have this double bond here. So this will be your final product. Okay? This will be your final product, yes or no? Tell me. Everyone, please check your product. Okay, very good. Right, everyone? Very good, everyone. Now, see, if you have doubt now, if you can't ask, then I'll upload this video on YouTube. You can just see that. Okay? Right? So I guess all of you understood what is Perkins reaction. So what is reactant? Reactant is aromatic aldehyde and anhydride, aliphatic anhydride. Reagent, tell me, base of anhydride. Okay? Right? Or aliphat or acidic base of anhydride having same group as anhydride. Okay? Product will be, right, your condensation product. Okay? Okay. Okay, everyone? Now, next is Novenzel reaction. It is called as Novenzel, K is silent, okay? Now, in this, right, you just have to remember the reaction. Even if you don't remember the mechanism, don't worry. You just have to remember the mechanism. Sorry, reaction, right? Okay, or it's rather simple. Okay, if you see the reactant, we have aldehyde or ketone and an active methylene group. Active methylene group means we have a methylene group with two groups, right? Two groups, right? And these two groups are your electron withdrawing groups. They are electron withdrawing groups. Z and Z dash, right, are your electron withdrawing group. Okay, got it? And the reagent, this is a substrate. Reagent is pyridine or piperidine, right? Pyridine or piperidine. Okay. Now, what is the product? It is also kind of condensation reaction. In short, what happens here, right? You will get final product. You will get carboxylic acid, or this is alpha beta unsaturated carboxylic acid, right? Okay. Now let's see the mechanism, right? Let's see the mechanism. As I said, ZZ dash can be these leaving groups. Sorry, these electron withdrawing groups. Okay, what happens here, right? What happens here? Now, we know that pyridine, right? Pyridine is also a base. Okay, so pyridine, when we have this ZZ dash is COOR in this case. In this case, it is COOR. Okay, Z is COOR in this case, right? Or if you think like this, it is just remove H2O first. Okay, so this R3N and we have H2C, what will happen? This will act as a base, yes or no? You have to know what is the work of any reagent. R3N is a base, so it will remove H plus, yes or no? Tell me, it will remove H plus, yes, agree, tell me. Now, if it will remove H plus, it will remove H plus, right? So this group, right, this H plus will be removed, so we will get this. Okay, this is Z dash, right? Z is COOR here. Z is equal to COOR. Okay, right? Anyone have any doubt in first step? Tell me. Anyone have any doubt in first step? Any doubt in first step? Clear? Now, if I give you this, suppose I give you this, what will happen? Tell me. I hope all of you are acquainted with this reaction now, right? We will have a condensation reaction over here. Yes? Tell me, yes? This carbon will attack here, right? So we will get this product or this intermediate. It's not product, it's intermediate, right? Anyone have any issue till this step? Tell me. Anyone have any issue till this step? Yes or no? Yes? Okay? Right? Now, this again, since H plus is taken, H plus is given back, right? So we'll have this. Okay? Right? Again, if we have O minus and if H plus is there, right? Right? Or in the form of RN3 and sorry, R3NH plus, right? H plus will be given, right? Because this is your acid now. Okay? So H plus will be given. We will get this. I hope anyone, right? Anyone have any issue till this step? No? Because obviously this reagent is your catalyst now, right? This is just your catalyst. Okay? Okay. Now, what do you think? If you give heat, what will happen? If you give heat, what will happen? Dehydration? Yes? Dehydration? Yes, exactly. Dehydration will happen. See how the mechanism is almost the same, right? In every reaction. So after dehydration, we will have this product. After dehydration, we'll have this product. Now again, we have 2Z here, right? We have 2Z here, right? So again, we have this reagent. And here it is given that minus CO2. So this is just nucleophilic. See, this is what? We have R, C, double bond C, H. Now this is attacked with C. Okay, double bond O, O, R, and C double bond O, O, R. Agree? Agree everyone? Okay. Now, if you give H2H plus, what will happen? If you give H2H plus, what will happen? How many of you remember this? If you give H2H plus, this will happen. How many of you agree with this? Because see, when you link each and every concept, right? Everyone, yes or no? After giving H plus H2O, this will be your product. OR will be replaced by OH. Yes or no? Right? Everyone have understood this concept? Same now, common sense, right? If you're giving OH slash H2O slash H plus, obviously OR will remove. You might think that how can this will be removed, right? This is not a living group. Is this whole a living group as it is? Tell me. No, right? Yes? Now, but if we give heat here, how many if we remember heating effect of carboxylic acid? Tell me, how many of you remember heating effect of carboxylic acid, right? Or dicarboxylic acid, we need soda lime slash heat. Yes, soda lime slash heat for removing CO2. But we had three cases in which we don't need soda lime. The first is gem dicarboxylic acid, vis dicarboxylic acid, right? Yes or no? First is, gem dicarboxylic acid, my bad. Right, so this is a gem dicarboxylic acid. Okay, we have 2 carboxylic acid at this carbon. So obviously one CO2 will be removed, decarboxylation. So we'll get this product. Now tell me, if I don't tell you the name of the reaction, just think about this. If I don't tell you the name of the reaction, right, and I just give you this whole reaction as a question, will this be out of syllabus? Think about it. Will this be out of syllabus? Forget about name of the reaction. I don't give you the name of reaction. I just give you the reaction and I'll say right? This is A, right? And this is B. Find A and B. Will this be out of syllabus? No, right? Got it? That's how the question is asked, right? Even if the name of reaction is not given. For example, I hope all of you heard of Darzin's reaction, right? Right, everyone? And there are many reactions, okay, which we have studied, but we didn't know the name, okay? Got it? So name wise, yes, it is out of syllabus. Name wise, it is out of syllabus, but don't consider, right, this as out of syllabus because this is just a condensation action. This problem have been asked already, okay? Not in J mains though, okay, in J runs for sure, okay? But my aim is to let you know how to, yeah, how to approach the condensation mechanism, right? And how to mix the concepts. Okay, everyone? Everyone is getting, right? Okay, very good. Now, next reaction, right? It is a very famous reaction. Okay, it is called as Rearrangement reaction. Okay, how many of you heard of Rearrangement reaction? Anyone heard of Rearrangement reaction? No, right? So this is one of the important reaction. Okay, Rearrangement reaction. So there are many reactions which is important, right? Rearrangement is one of them. Okay, yeah. So when you talk about Rearrangement reaction, as I told you, right, whenever you write or make notes of your name reaction mechanism, you have to see what is your reactant. Reactant is benzaldehyde, okay, benzaldehyde and alpha haloester. Remember this, alpha haloester. Okay, got it? Got it, everyone? So in Rearrangement reaction, right, we have alpha haloester and aromatic aldehyde. Okay, got it? Aromatic aldehyde or any aldehyde. Doesn't matter aromatic aldehyde, you can have any aldehyde also. Okay? Because again, by seeing, you must have gotten the idea what will happen. Tell me. How many of you got the idea that what will happen? Tell me, just raise your hand. How many of you got the idea, right, that what will happen over here? By seeing the reagent is Zn, right? If you remember, right, RBR, right, or C, BR, Zn, right? I hope some of you might relate. If you remember alkene, then you can relate that what is the work of Zn. No one is raising their hand. No one remember. No one is getting the idea that what will happen. Yes, exactly. See, right? Zn, the Zn will remove this Br. Yes or no? Zn will remove this Br. Agree? Then we will have this negative charge. Agree? And this will attack on this aldehyde. Same mechanism again. Agree? Tell me, isn't the mechanism repeating itself all the time? Right? See, that's the thing, right? Doesn't matter if you change the reaction, the mechanism will not change. Okay, the reactant may change, the reagent may change, right? Product may change, but mechanism will be same, right? So obviously, see the mechanism step by step. Zn, so Zn will react with ZnBr. If you remember, Zn is also one of the most important reagent in the formation of alkene from dihalide. Yes, everyone remember now from dihalide? Okay, so and Br. What do you think? What is this? Isn't it the same as MgBr? This is also one. organometallic compound? Tell me yes. Yes, everyone, right? Instead of Zn, I can take Mg also. Can I? Because it is just acting as a Grignard reagent. Yes or no? It is just acting as a Grignard reagent because Grignard reagent give me carboanion. As simple as that, right? And I need carboanion because I need a nucleophile. Got it, everyone? Tell me, got it? I need to remove Br, not as Br minus, but Br plus. Okay? And there are two ways, right? Actually, there's one way, right? Convert it into organometallic compound. Got it, everyone? Now, do you think that we have studied each and everything in our normal class? Right? I'm just linking those concepts. Okay? Okay, everyone. So once this is formed, right, then it is easy. It will attack on this carbon, right? This is your nucleophile. And O minus, instead of H plus we have Z and Br. So if you give H plus, it will be removed. You will get this. Yes or no? Yes or no? Right? Agree? Agree, everyone? Now after heating, it will form cinnamic acid, right? This. Yes. Now if you remember, we have formed this product by one more method. Tell me, what is the method? Tell me, everyone. Let's see how good your memory is. We have formed this product. Yes, Harsha, very good. Everyone should answer. Everyone should answer. We have formed this product by one more method. Okay? No, Vishnu. It was not calculation. We have formed the exact same product. Tell me, everyone. I've specifically told you that this is the name of the product, right? No, Shreya, it was not Novenzel. It was Perkins reaction. Yes or no? It was Perkins reaction. Okay, right? Remember, everyone? It was Perkins reaction. Okay? Okay, everyone. Right? See, I request all of you to please watch this video once again, make your own notes, write down. If you don't write your mechanism, don't worry, but write down reactant reagent product. Okay? Then next is Cannizzaro reaction. Right? So this is one more reaction that we have studied. Very easy reaction. It is just as aldol, but it is not aldol, right? Reactant and reagent are almost same as aldol, but the only difference is the aldehyde and ketone here do not contain alpha hydrogen. Right, everyone? Right? Okay? And it is not a condensation reaction. Cannizzaro is not a condensation reaction. It's a redox reaction. Yes or no? Yes, very good, Harsha. It's a redox reaction. It's a disproportionation reaction in which, right? Yes, in which the reactant is both oxidized as well as reduced, right? Now, this is very easy. This is very easy. Now, my question would be, suppose I'm having two different type of Cannizzaro, which is cross Cannizzaro. Okay? Suppose I'm having HCl1O H plus 5CL1O H. Now tell me, which will be acid, which will be alcohol? Tell me, which will be acid, which will be alcohol? Everyone, think about this. Which will be acid, which will be alcohol? How, see how the concept remains same. You have to think. Yes, very good, Harsha. Very good, Sumedh. See, when you talk about the mechanism, the first step is what first step? Attack of OH as a nucleophile, yes or no? The first step is attack of OH as a nucleophile, like this, because here we don't have acidic hydrogen. So OH will not act as a base, it will act as a nucleophile. It doesn't have any other option, right? Now, the non-intuitive thing that will happen over here is removal of this H. Removal of this H, right? Now, since this is non-intuitive, this is the non-conventional step. That is why it is your rate determining step. Okay, right? Removal of H minus. Removal of H minus is your rate determining step. Guys, can you hear me clearly? Because I again got some call. Or is my voice became low? Tell me. Audible. Clear, right? Okay, there's no change in. Okay, very good. So that is why the removal of H minus, remember this H minus hydride transfer is your rate determining step. Okay, hydride transfer and proton exchange are not the same thing. Proton exchange means H plus transfer, right? Hydride transfer means H minus. Okay, that's the thing. Now, if you think about the step, I know that whole step is your nucleophilic addition. Okay, got it, everyone? So when we talk about nucleophilic addition, obviously nucleophile will be added in that substrate which is statically less hindered. That's why you have to keep this in your mind. Okay, OH will attack on that substrate which will be statically less hindered. Hence, carboxylic acid will be that substrate which will be statically less hindered. Okay, everyone, got it? So that was cross Kanizaru. So I hope everyone remember this cross Kanizaru. Okay, so this is a general reaction. Even if we have two different aldehyde or two different ketones, right? Your carboxylic acid will be that substrate which will be less hindered. Okay, right, everyone? Now, next is intramolecular Cannizzaro that we have already studied. If it is symmetrical, doesn't matter what you do. If it is non-symmetrical, less hindered side will be your carboxylic acid. More hindered side will be your alcohol. As simple as that. Okay, got it, everyone? So if anyone needs, I'll send this to you. And see, I'm saying this upfront, right? Module will be more than enough, right? Module previous year, right? And the material that ma'am is sending is more than enough for your JEE mains, NEET, right? But if someone wants to practice more, okay, I've already said DK Singh for NEET, okay, and MS Chauhan for advanced, right? But if you want something more, or if MS Chauhan is difficult, you can ask me, I'll send you the material, okay? But focus on NCRT. I'm again saying, Vishnu, Manoj, especially for you to focus on NCRT. NCRT should be on the tip. Okay, next is also quite a famous reaction, right? In aromatic compound, you will study this in aromatic compound usually. Okay, this is called as benzylic rearrangement. Okay, now we haven't studied many rearrangement reaction. Yes, everyone, but there are few rearrangement reactions which are quite famous. Okay, right? Have you studied any rearrangement reaction till now? Tell me, because till now what we have studied was condensation reaction. Now when we talk about rearrangement reaction, okay, so we have Beckmann rearrangement, then we have, yes, pinacol. That's a basic carbon rearrangement, right? Pinacol, pinacolone, okay, right? Then we have Beckmann, then we have this schematic rearrangement reaction, right? Then we have Beer-Villiger. All of them are your rearrangement reactions. Okay, so let's see. Now, before covering benzylic, right? I'll cover Beckmann rearrangement. How many of you studied Beckmann rearrangement? Has it been covered? Tell me. Beckmann rearrangement? Yes or no? Yes? Right? All of you remember? Tell me yes or no? No? Okay. So let's cover Beckmann rearrangement first. It was not there in the list now. So when we talk about Beckmann rearrangement, right? It is Beckmann rearrangement. Pardon me if I'm making some spelling mistake, right? Beckmann rearrangement. Now again, this is a rearrangement. As the name suggests, right? It will almost be same as carboxylic, sorry, carbonyl rearrangement, but obviously there would be some difference. Okay. Now tell me, I'll just ask you step by step. Okay. So I'm having this. I hope all of you remember this reaction. Yes, tell me, everyone remember this reaction? Everyone remember this reaction? Is there anyone who doesn't remember this reaction? If you don't remember this reaction, please go through, right? I'm saying again and again, in class 12th, NCERT is your Gita Bible, right? Quran, whatever you think, okay? You have to read NCERT line by line. Yes. So what will happen, right? This H2 will be removed, right? This H2 will be removed. I'm just making the product, okay? Because I expect you to know this reaction. So this will be your product. Agree? Agree, everyone? Okay. Now, after this, if I will give you conc H2SO4, conc H2SO4, okay? Right? First, I'm giving conc H2SO4. What will happen? Tell me, what will happen? What do you think? Be very intuitive. Conc H2SO4 means H plus. I'm giving H plus. Yes, very good. So what will happen? This OH, right, will be removed. Yes, very good. So I'll get something like this. Yes, you can just, it won't be plus, it will be something. Okay, you can just write plus over here, it's fine. Actually, it will be an intermediate called as, this is called as nitrene. Nitrene, this is one of the intermediates, right? Carbocation, carboanion, right? Then we have free radical, then we have carbene, then we have nitrene. Okay, this is like nitrene. Okay, got it? Now tell me, this nitrene is your electron deficient or electron uh, rich? Deficient, yes. Now think about this. Suppose if you had this C plus, right? Right, everyone? what would have happened? This R will shift to this side, right? Carbon rearrangement, if you remember, then you would have something like this. Yes or no? Yes? Agree? Agree, everyone? Yes or no? Tell me. Yes? Same, this thing would have happened. Now, isn't it the same case? Isn't it the same case? I'm just using the concept that you have studied. That's it. I'm not teaching you anything else. I'm not teaching you anything new, right? So since it is electron deficient compound, sorry, group, atom, right? I can say that this R will shift over here, right? Or better, I'll just write it like this. Okay? Why I'm shifting this R? The answer lies in this orientation, right? Because you may ask, so why this R? Or I'll just write like this, R dash, R dash, right? So you might ask, so why only R dash? Why not R? So that's the thing in Beckman. The group which is anti to OH, right? The group which is anti to OH will migrate, okay, right? Then obviously after migration, what you will get? You will get something like this. C plus double bond N or just plus R dash. Agree? Tell me, agree? Anyone have any doubt in this? Tell me, anyone have any doubt in this? No? Anti to R, anti to OH, Harsha, anti to OH means opposite to OH. Okay. Any group which is opposite to OH will migrate. Okay. Right? Because you might be some option and there will be two R, so you might be confused that which R will migrate, right? So according to, especially for Bachmann rearrangement, this is specifically for Bachmann rearrangement, by the way, right? The group which is anti to OH will migrate. Okay, everyone? Wait, everyone. I'm getting lots of calls from some students. Okay, sorry everyone, I was just getting lots of calls. Okay, so yeah, got it, right? Anyone have any issue till this step? Tell me, anyone have any issue till this step? No? Now, what do you think? What will happen now, right? We still have H2O plus, right? We still have H2O. Yes or no? We still have H2O, right? Now, don't you think that this H2O will act as a nucleophile now? Because we have C plus, right? So this H2O will act as a nucleophile. Yes or no? This H2O will act as a nucleophile. So we will get what? We will get this R, C, OH, double bond N, R dash. Agree? Agree, everyone? Tell me, agree? Then after this, tautomization, right? Tautomization. Okay, because we have H plus. So it will become what? R, C1O, NH, R dash. Got it? Got it, everyone? Tell me, yes or no? Yes or no? Right? Now, if you see your reactant was this. Your reactant was this, which is your ketone, right? In this ketone, okay. This ketone, right? In this ketone, you're just inserting NH. Yes or no? Tell me, yes or no? Agree, everyone? Right? You're just inserting NH, right? So if I say, what is the overall reaction? What's the overall reaction? So my overall reaction is this: R, Sil1O, R, right? React with H2OH slash found H2SO4, right? Will give me R, C, O, NH, R. Or if you put it R dash, so R dash. Got it, everyone? Tell me, everyone got this? Yes or no? Tell me, got this? Okay. Anyone have any issue? Tell me. Anyone have any issue till this point? See, Harsha, rearrangement is done to see. The thing is, right? Frankly speaking, we don't know why this happens. Okay, because when we talk about mechanism, it is a hypothetical process. Okay, this happens, right? That's a fact. Then we think, okay, this might have happened like this. Okay, right? Because you cannot say that out of these two, which is your stable, both are stable, right? Both are stable. Okay, right? But these reactions, then it will converge with this product. Okay, right? That's why it is very important to know the work of reagent. For example, instead of NH2OH, it can give any other reagent which can add N. Okay, which can add N. For example, they can give you N3H also. Okay, instead of NH2OH, they can give N3H also, right? They can give anything which can add N. That's why I broke down this reaction in two steps, right? First was formation of nitrene and second was this, okay? Because in order to form nitrene, you can give any reagent. You should know the work of reagent, okay? Okay, Asha, got it? Right, everyone? Okay, now we don't have time. Uh, I guess I'll take one more extra class. So I hope all of you remember these six reactions, right? We have done the mechanism of these 6 reactions, right? Okay. So I'll take one more class, like apart from Azra's ma'am class, right? If she'll teach in the class, well, no issues. It will be just revision for you guys. Okay. Okay, everyone. So I hope all of you learned something. Okay. Yeah. So most of you take one extra class either on Sunday. Okay. So in that we'll discuss some other reactions, which is Bayer-Villager, then your Riemann reaction, Benzylic, right? And all the reactions which is not covered. Okay? Okay, everyone. Okay, bye everyone. Thank you. Yeah, bye everyone. I'll upload the video on YouTube, so if you want to see again and make your own notes, you can do that. Okay? Bye everyone.